Hi there, Mr. Sutton here with the AB Calculus 4-3 Extra Practice Number 3 solutions on local extrema. To find the relative extrema on this function, we have to figure out where the derivative is changing sign. So let's first get a derivative, f prime. That's going to require the quotient rule on this one. So let me set up my box and ribbon to help with that. And I've got a negative fraction. That means either my numerator or my denominator is negative. I'm going to put the negative with the numerator. So I'll call this negative 4x up here. And then I have x squared plus 4 as my denominator. Now I need their derivatives, which would be negative 4 and 2x. And then putting this together, we've got u prime v minus uv prime over v squared. So I'm going to use the ribbon kind of pattern to do that. This is going to be, and I'll just distribute as I go here. So this is going to be negative 4x squared minus 16. And then going the other way, this is minus 4x times 2x, so that's going to be positive 8x squared, all over this stuff, x squared plus 4, quantity squared. And let's clean this up a little bit. Combining my x squareds, I've got 4x squared minus 16 in the numerator. So I want to figure out where this fraction is either 0 or undefined. So let me set the whole thing equal to 0. But really, if I'm talking about zeros, I need to make the numerator 0. I can do that by first factoring a 4 out of here. So that's going to be x squared minus 4 inside. And then if I set x squared minus 4 equal to 0 and solve, let's see here, add 4, square root both sides, we get plus or minus 2 as the critical values from that. Now looking at what makes this fraction undefined, if we try to zero out the denominator, we're kind of out of luck on that one because we've got only 0 or positive numbers coming out of this x squared, and you're adding a 4 to it, so you're never going to get 0 out of this. So then we only have to consider negative and positive too. Let's go to the f prime number line here. And we've got those critical values being mapped out. I'm going to test a value in each of these intervals. To the left of negative 2, let me try out negative 3. And I'm going to use this fraction up here to figure out what's negative and what's positive. Now actually I don't really need to use this fraction even because the denominator here comes out positive no matter what. I mean, you're squaring whatever comes out of this. So because my denominator is automatically positive, it's really only the numerator I need to consider. And it'll probably be easier to do sign analysis on the numerator if I just use this factored version right here. So plugging in negative 3 here, this is going to be 9 minus 4, which is a positive. Now between negative and positive 2, I can use 0. That's going to be 0 minus 4, which is negative. And then after 2, I'll use 3. That's again 9 minus 4, which is again positive. Now I notice in terms of f prime signs that f prime is changing from positive to negative at x equals negative 2. Therefore, f has a relative max at x equals negative 2. And f prime is changing from negative to positive at x equals positive 2, giving f a relative min at that spot. For this polynomial, I'm trying to figure out relative mins and maxes. So I need to figure out sign changes in f prime. Let me start by getting f prime and finding critical values. So f prime, using my power rule, we've got 6x squared plus 42x plus 36, and then that negative 20 just turns into a 0. So setting this equal to 0 and solving, I notice that I can factor a 6 out of all this. That'll leave me with x squared plus 7x plus 6. And that's easy to factor, just two things that multiply to 6 and add up to 7, x plus 1 and x plus 6, which means that my critical values are going to be at x equals negative 1 and negative 6. So here's my f prime number line to graph those out. We've got negative 6 and negative 1. And now I'm going to test values to the left of negative 6 to start with here. Let me try out negative 7. I'm just going to use this factored version of f prime. So plugging in negative 7 for x, that gives me a negative times a negative, which is a positive. And then between negative 6 and negative 1, let's try negative 3. So that's going to be a negative and a positive, which comes out negative. And then bigger than negative 1, let me use 0. So that's going to be positive, positive, which is positive. Now I notice that f prime is changing from positive to negative at x equals negative 6. So that means f has a relative max at that x value. And then f prime's changing negative to positive at x equals negative 1. So that means f has a relative min at x equals negative 1. To find relative extrema for this function, I need to figure out where f prime is changing sign. f prime of this stuff is going to be 4x cubed minus 6x. And now I have to set that equal to 0 and find some critical values to do sign analysis around. I can start by taking out a 2x. That leaves me with 2x squared minus 3 inside. And then I see that the values of x that make this whole thing come out to 0 are going to be 0 for this 2x. And for this parentheses here, if I add 3 and divide by 2 and then square root, I've got plus or minus the square root of 3 over 2. There we go. So this is actually 3 critical values to put on my f prime number line and test around. I've got negative root 3 over 2, 0, and positive root 3 over 2. So now let me test a number to the far left here. Root 3 over 2, that's somewhere between 1 and 2 numerically. So if I do negative 2, that's going to be a little bit to the left. Now when I use my sign analysis, I'm going to use this factored version of f prime. So plugging in negative 2 here, that's going to give me a negative outside, and inside this is going to be 8 minus 3, which is a positive. Negative positive gives me a negative result. Now between negative root 3 over 2 and 0, I can use negative 1. Plugging that in, I get a negative, and then this is really 2 minus 3, so that's also a negative inside, so overall positive result. Between 0 and root 3 over 2, that's going to be 1. That's a good number to use. That gives me a positive times a negative, which is negative. And let me use 2. That's a number bigger than root 3 over 2. So that's going to be a positive times a positive, which is positive. Now I notice that f prime changes from negative to positive in 2 spots at plus or minus radical 3 over 2. Therefore, f has a relative min at both positive and negative radical 3 over 2. And I also notice that f prime is changing from positive to negative at x equals 0. So therefore, at x equals 0, f has a relative max. On this one, I'm trying to find relative extrema for this function. So that means I need to figure out where f prime is changing sign one direction or another. What is f prime for this? Well, if I take this derivative, I'm going to use the chain rule. I've got something to the 1/3 power. That derivative is going to be 1/3 times the something, which is 5x plus 15, to the negative 2/3. But I also have to multiply by the derivative of the something, which is going to be a 5. So that's times 5. Let me clean this up a little bit because I'm about to figure out where this thing is either 0 or undefined. And in this form, it's kind of hard to tell. So I've got a 5 in the numerator, and in the denominator, I've got a 3 and a cube root of all this stuff in the parentheses. And it's all being squared too. That's what this 2 is doing. So now, trying to set that equal to 0, I notice that I can't make this thing equal 0 because I have a constant in the numerator. However, I might be able to make this thing undefined somewhere. Cube root means that I don't have to worry about taking roots of negative numbers because cube root can handle that. But if this whole thing comes out to 0, then I'm in trouble. So if x equals negative 3, so that I have negative 15 plus 15, that zeroes out my denominator. So f prime then does not exist at x equals negative 3. Now, before we do sign analysis on this, it's worth noting that because I'm squaring all this stuff here, the numerator is going to end up positive no matter, or the denominator ends up positive no matter what. The numerator is already positive. So that means this whole fraction, as long as x is not negative 3, this whole fraction, f prime, is always going to be a positive number. Since we're not changing positive to negative or vice versa anywhere, since there's no sign change in f prime, that means that there is not going to be any kind of relative extrema for this function. For this problem, I'm trying to find relative mins and maxes for this polynomial. So I need to know where f prime changes sign, which means I need to know what f prime is. So taking my first derivative, that's going to be negative 6x squared plus 12x, and then that 3 is going to be 0. So I'm going to set this equal to 0 and solve for critical values. I can start by factoring out a negative 6x, leaving me with x minus 2. So then I have critical values at x equals 0 and positive 2. Let me stick those on an f prime number line, so 0 and 2. And now let me test something to the left of 0, like negative 1. I'm going to use this factored version of my f prime. So plugging in -1, that gives me a positive times a negative, which is negative. And then plugging in something between 0 and 2, like 1, that's a negative times another negative, which is positive. And bigger than 2, let's use 3. That's a negative times a positive, which is negative. Now I notice here that f prime is changing from negative to positive at x equals 0. So that means f has a relative min there. And f prime is changing positive to negative at x equals 2. So that means f has a relative max at that location. For this problem, I'm trying to find relative mins and maxes for this quintic function. That's a word you don't hear too often, quintic, fifth power. So I need to know where f prime is changing sign. F prime is going to be 5x to the fourth minus 10x, and then that 1 is just a 0. So I'm going to set this equal to 0 and solve. This ought to be interesting. I can start by factoring out an x, leaving me, and actually a 5x. So that's going to leave me with x cubed minus 2. And then setting each of these equal to 0 and solving. This whole thing is going to be 0 if x equals 0 for that 5x part. Or if we add 2 and take the cube root of 2 would also do the job. Those are my critical values I'm going to put on my number line now. So here's my f prime line. Critical values at 0 and cube root of 2. Let me test something to the left of 0 to start with here. So I'll use -1, and I'm going to use the factored version of f prime. So plug in -1. That's going to be a negative and another negative in here, because this is going to be -1 minus 2. So that comes out to a positive. Now between 0 and cube root of 2, well, what would even be between there? The key on this is realizing that the cube root of 2 is a little bit bigger than the cube root of 1, and the cube root of 1 is just 1. So if you pick 1 for your number, that will be between 0 and cube root of 2. And if I plug 1 in here, I've basically got a positive, and this is going to be 1 minus 2, so that's a negative overall result. And then something bigger than the cube root of 2 would just be plain old 2. So plugging that in, I've got a positive comes out positive. So f prime is changing from positive to negative at x equals 0, meaning f has a relative max at x equals 0. And then f prime's changing negative to positive at the cube root of 2. So that's the location of f's relative min. On this one, I want to find the relative mins and maxes for this weird looking function. So let me start by taking the derivative, because I'm looking for f prime sign changes when I'm looking for relative mins and maxes. The derivative, well, this is going to require a little bit of a chain rule. We have negative something to the 2/3. Derivative of that, the outer derivative, is going to be negative 2/3 times something to the negative 1/3. But now we have to multiply by the derivative of the inside here, which is -1. So we have a little -1 out there. I'm going to clean this up a little bit too, put it in fraction and radical form, because I found that it's easier to find zeros and undefined spots when I'm in that form versus what I have here. So obviously the -1 and the negative 2/3, now that's a positive 2/3. I have a 2 in my numerator. In my denominator, I'm going to have the cube root of -x minus 2. So there's what I'm really looking at when I simplify this a little bit or change forms. And I want to find out where f prime is either 0 or undefined. Well, since I've got a constant in my numerator, this will never be 0. So it's really the undefined spots that are going to give us our critical values. And the only spot where this is undefined, since this is cube root and I'm not worried about taking roots of negatives in that case, the only spot that gives us issues is if I plug in -2 for x. That would be a -2. That would be positive 2 minus 2 would give us a 0 in the denominator. So this is undefined at x equals -2. So that gives us our lone critical value to put on our f prime number line. Testing something now to the left of -2, like -3, and taking a look at this here. This is -3, so that's +3. -2 is a positive number. So the cube root of that is also a positive number, meaning this whole thing is positive. So that's a big positive right there. Now if I plug in something to the right of -2, like 0, well now I have -2 cube root there, which is negative, making this whole thing negative. Since f prime is changing positive to negative at x equals -2, that means that f has a relative max at that spot. On this one, I want to find relative extrema for this polynomial. So I need to know where f prime is changing sign. Let me start by taking the derivative. So that'll be 3x squared minus 20x plus 28, and then that negative 19 is just 0. So I want to figure out where this equals 0. This is actually factorable, or you could use quadratic formula. If you factor it, you're going to get a 3x and an x, and through probably a fairly lengthy trial and error process, you end up with 3x minus 14 and x minus 2. Now, I'm not going to go through that process, but just to prove that this is actually correct, 3x times negative 2, that's negative 6x, and then we have negative 14x if we do the inners, so negative 6x and negative 14x does add up to this negative 20x in the middle. So this works. Now that means that we have critical values at x equals, let's see here, adding 14, dividing by 3, that's going to be 14 thirds, and also positive 2. So that's what we're putting on our f prime number line. And let's see here, 14 thirds, that's bigger than 2, so we'll do 2 first and then 14 thirds. Let me test something to the left of 2, like 0, and I'll use this factored version of f prime. So that's going to be a negative and a negative, which is positive. Now something between 2 and 14 thirds, 3 definitely works. That's going to be, let's see, 9 minus 14 is negative, 3 minus 2 is positive. So positive or negative positive gives me a negative overall. And then bigger than 14 thirds, well, how about 15 thirds, aka 5? So that's going to be 15 minus 14, which is positive. 5 minus 2 is positive, so overall positive. And I notice the f prime is changing positive to negative at x equals 2. So that means f has a relative max at x equals 2. F prime changes negative to positive at x equals 14 thirds. So that's the location of a relative min.